We go to the first session in the morning. The chair is Chenzhou Cui. I know he is here. And the subject for this session is Big Data in Education. Chenzhou, are you there?
Yeah, I'm here. Can you hear me, Bias?
Yes, very good. This time is yours. You have session number 7. And you have 1 hour for the session. Thank you very much.
Okay, thank you, Bias. And good morning, good afternoon, good evening, everyone. My name is Chenzhou Cui, and I came from the National Astronomical Observatory of China. Right now, my colleague Shanshan Li shared the presentation with you. Shanshan Li is my colleague. And this session, the title is Big Data in Education Science. And I'm very happy here with 4 speakers for this session. And we have 4 talks and 1 hour. So each one will have 10 minutes. So this is now 5 minutes past the hour. Let's invite the first speaker, Baerbel Koribalski. Is it?
Yeah, that's correct. Thank you.
Yeah, from CSIRO from Australia to give us the talk about open astronomy and big data science. Welcome.
Hello.
Hello. Yeah, so please share your screen now.
Can you see my screen?
Yeah, yes. Good.
Okay. So my talk is entitled Open Astronomy and Big Data Science. First up, I wanted to let you know any questions you have or help you may need with the data that I talk about. Here is my email address. I'm happy to help. Very familiar are probably all of these open astronomy tools that I've listed here. I couldn't do with any of them. I think most of them I use every day, be it the Astrophysics data system or the NASA extragalactic database, Archive, Skyview, Vizier, Aladdin, ESA Sky, as Shanshan already mentioned. It's, I think, absolutely wonderful that we have these open astronomy tools that everybody around the world, astronomer or not astronomer, can use, and there's certainly many more that I've listed here. So I think this is a great community that creates these tools that we can all share. Since I have a very short talk, my following slides will be about the Australia Telescope National Facility, the telescopes we have, and the data that we make available. So we have the Parkes 64-meter telescope, a giant telescope, and getting old, but still world-class with world-class receivers. The Australia Telescope Compact Ray on the top right with 6 22-meter dishes spanning 6 kilometers, and the very new Australian square kilometer array Pathfinder ASCAP in the bottom left. Now on Parkes, the multi-beam receiver served us for over 20 years. It has now been taken down and a new receiver has been put up. So there's lots of data in the archive for anybody to explore. The compact array has a broadband system that's nearly 10 years old, and that will also soon be replaced by an even broader kind of system, more sensitive. And ASCAP, of course, has a very new technology. The phased array feeds that you see in the picture that look like a checkerboard allow us to form 36 beams in one go. And the field of view that we cover in one observation is 30 square degrees. Now, if you're interested in Parkes data, you can find them in 3 different places. In the Australia Telescope Online Archive, you find all the raw data. In the CSIRO Data Access Portal, you find, for example, pulsar observations. So if you're interested in pulsars, that's the place to go. And you also find all our HIPAS cubes. Now, HIPAS was an all-sky survey in the hydrogen line, detecting over 5,000 galaxies, and you can obtain the images and spectra there, or go straight into the HIPAS spectral data release that's on the bottom left, type in your object name or coordinate, and up will pop the spectrum or a non-detection if it doesn't have any H1. So if I go on to the ATCA, the Australia Telescope Compact Array, the data are also in the archive. This is the raw data. That's partly why I offered my help, because not everybody is familiar how to make images from the raw data, which have visibilities in radio astronomy. So we have now over 100 terabytes of raw data in the archive. For this project that I'm highlighting here, which was one of the largest on the compact array with over 2,500 hours of observing time, you can obtain all the data cubes and maps of nearly 100 galaxies from my Elvis homepage and its database. So this is a local volume H1 survey, just the nearest 100 galaxies that are rich in H1, about 25 of them are shown there, can be obtained through that archive, and I'm happy to help with any of that analysis if you're interested. Now, the newest telescope is ASCAP. It's not yet in full survey mode, but the telescope is ready, and I hope we can start the full surveys next year. The biggest surveys are Wallaby and Emu. You can already see the Australian theme here. The projects were mostly named after Australian animals. I created the Wallaby project in 2009. We had hoped to conduct it much faster, but here we are, close to starting it next year. It will survey all the sky ASCAP can see and detect around 500,000 galaxies in H1, while the EMU project is a complementary radio continuum project, and it's expected to detect 70 million radio galaxies. Now, at the top left, you see the CSIRO data access portal. All the currently available data from the pilot service and early signs are available in that archive. So for example, if I go to Wallaby, we've conducted over 500 hours of observations of hundreds of galaxies, some of which are shown on this slide. To find these galaxies, we also created a particular piece of software, namely SOFIA. This is our source finding software. I say a little bit more about it in the next slide, but in this slide, I wanted to also highlight that we're not only finding H1 in galaxies. In fact, it becomes particularly exciting when we find hydrogen clouds without any stars, so-called dark hydrogen clouds, most of them being tidal tails or rings around galaxies, places where not a lot of stars have yet formed. So with optical telescopes looking very, very deep, we can sometimes see the first signs of star formation. So the software here, SOFIA, is publicly available on various websites. At the bottom there is Tobias Westmeyer's webpage where you can obtain the latest version. We now have two versions, one that runs in Python and people can contribute to this package, and another one that has been parallelized, SOFIA 2, that runs very efficiently on supercomputers and will be used for the Wallaby project and also Meerkat projects and other H1 projects or spectral line projects, let's say ALMA, CO, H-alpha projects. You're welcome to use it and adapt it to your needs. This package also contains the busy function, which we developed. If you're interested in the busy function, then have a look at Tobias's paper. It's a very, very useful function to fit double horn profiles accurately and analytically, which wasn't possible before. The EMU project has already completed its pilot survey and all the data are public. This was 10 fields, each 30 square degrees, so 300 square degrees in total, The data can be explored in various ways, for example, through the HIPS maps, which you can surf like you do a Google map, zoom into your objects, explore them. I think around 200,000 radio galaxies have been catalogued in that project, and the publications are underway. Here is one of the papers or just a glance at one of the papers Ray Norris has just published, where we found a new phenomenon. We're not quite sure what this ghostly ring is. A galaxy in the center could be the host. We have dubbed them orcs, odd radio circles, and if you find some, let me know. We have a handful of orcs at the moment, and we're still investigating what they may be. Quite likely far away and quite large. Excuse me?
Yeah, 1 minute. 1 minute.
Yeah. The other survey that we have just released is RAX, the Rapid ASCAP Continuum Survey. It's a rather shallow continuum survey of all the sky that ASCAP can see. So it's not as deep as the EMU survey will be, but significantly deeper than the previous NBSS survey. And this picture shows some of the highlights that have been discovered from beautiful supernova remnants and radio galaxies. There is 1 million new galaxies in here, and all the data is available for anybody to download and explore. And I invite you to please look at these data and play with these data and have a lot of fun with them. And that already concludes my presentation. I thank you very much for listening.
Thank you, Baerbel. Yeah, so any questions for her talk? Very good talk.
Thank you.
Is there any questions?
No, sorry, Chenzhou, the questions at the end of the session. Go one talk after the other, and all the questions at the end of the session.
Okay, good. So,
okay, thank you.
Yes, see you later. Okay, so let's move forward to the second talk. The second one is from Agra, from Byurakan Astronomical Observatory, and also the Armenia Virtual Observatory project. So welcome, Areg.
Thank you very much. So my talk is about the role of big data in astronomy education. Actually, big data plays an important role in any aspect of astronomy, and astronomy is now fully, let's say, engaged into big data. Of course, we all understand that the biggest data come from the universe. Of course, the Earth itself is very small compared to the whole universe. And first of all, if we speak about big data, then we speak about the universe, data coming from the universe. I am representing Byurakan Astrophysical Observatory from Armenia, and also the regional office, the IAU regional office of Southwest and Central Asian region. So we are a region from European borders to the Central Asia. And also we have Armenian Virtual Observatory, which is related also to big data, and we are part of the International Virtual Observatory Alliance. And by the way, our session chair is the chair of IVOA, Professor Cui. And also we run Byurakan International Summer Schools, which are also important because many of these schools have some relation to big data. For example, the last one in September this year, we devoted to the data science. So I will speak about astronomical data in general, surveys, catalogs, databases, archives, any form of data, big data in astronomy, literature, software resources, educational resources, and our schools. I will mention what we are doing and invite all young people to participate in our school. Astronomy is now both multi-wavelength and multi-messenger. So we have a lot of data coming from various wavelength ranges. And you see just, for example, here for Milky Way, we have so different pictures compared to the optical one. And recently, during these recent years, we obtain a lot of data from various telescopes, both ground-based and space, and each gives its own data. So to have an overall picture of the universe, we should combine all this, and we should actually use everything together, which is actually the basis of the virtual observatory. One example coming from Byurakan survey. This is Mickaelian survey, very important astronomical heritage, which is included in UNESCO's lists. This is very rare item in UNESCO's list coming from science. Maybe there are a few dozens only among thousands of different items which are inscribed in UNESCO. So this is a spectroscopic survey giving about 40 million spectra for 20 million objects, but of course low dispersion spectra. So the information is not very big. We have only 107 pixels, but it is very good for teaching and also for training to use together with Gaia spectra. These are very similar to Gaia spectra, and it is very important that we have already such a background. Another example is Sloan Digital Sky Survey, which is already giving spectroscopy of medium resolution, let's say, and a lot of data also for photometry in 5 bands. So this is the largest database, maybe what we have until now, but also Gaia is coming, and the 3rd data release is already available. Here are the data. You see how many objects have what kind of information, including both astrometric and astrophysical. Gaia is a very good example to teach to students how astrometry, which was considered as a very old branch of astronomy before, now plays important role to understand the astrophysics. So having astrometric data, now we can calculate many astrophysical parameters, as you can see here: color, let's say temperature, luminosity, etc. So all astrophysical data now are available after having this Gaia data. So it is important to emphasize to students that astrometry, even astrometry, somewhat old branch, can also play important role for present, for modern science. This is an example of astronomical catalog, the picture actually of biggest astronomical catalogs, the table. And here you see Supercosmos, which is based on digitized sky surveys, then Gaia, 3rd data release, Sloan, and some surveys based, as I said, on digital sky survey, but different catalogs like USNO, Sky catalog, All-Wise in near and mid-infrared, and TUMAS in near-infrared. A comparison of important all sky or large area surveys. Here is the number of objects. This is 1 billion, and limiting magnitude. So as you see here, we have deep surveys, and the largest surveys are here. Then I made some comparative analysis of number of objects from different wavelength ranges. And this is, of course, approximate numbers, but we have somewhat 2.4 billion objects collected in different astronomical catalogs in optical wavelength. Then near-infrared, mid-infrared, even now it is more than 600 million. And you see here a logarithmic scale, and the numbers in some ranges are so small that even in logarithmic scale we don't see actually anything here. So most of data still are in optical and some neighboring wavelengths, but I think gradually astronomy will become fully multi-wavelength, and the sensitivity is important to be increased in other wavelength ranges, then we will have more and more objects. Having all this data, this is very nice picture to show what kind of astronomical data are accumulated in astronomy. So we have observational data coming from different telescopes, instruments, analysis, publications, etc. And virtual observatory comes to unify all these. And this is very important that astronomers have created such kind of e-science. Probably astronomers are most advanced in all sciences, having such developments like a virtual observatory. And this is the International Virtual Observatory Alliance, having 19 national projects and 2 European, so 21 projects. And Armenia also is in this family. And finally, just an example how astronomers combine data coming from different telescopes, and then this is very useful to show to students how we can have data in different colors. We have data from different telescopes, and this is the theoretical curve. And when we combine these and fit to the model, so that we have the more or less good picture which can be believed to be true. So, very many software like this, like VioSpec and similar, are available now. Virtual observatories give, for example, the IVOA site gives.
Excuse me, Areg, 1 minute left.
Yes, I am finishing. Thank you. So there is tutorials and some sites and menus for teaching astronomy using virtual observatory tools, and this is very important to use. Actually, my talk was about this, the role of big data for teaching astronomy, for astronomical education. Thank you very much.
Thank you, Areg. And so let's move to the third speaker. Our third presentation came from NAOJ, National Astronomical Observatory of Japan. Kumiko Usuda-Sato. Are you there?
Yes, hi. Hello,
Yeah.
do you hear me?
You're good.
Hi. And do you see my screen?
Sure, yeah, very good.
Great, okay, can I start?
Okay, so please go ahead.
Okay, thank you so much. Hi, good morning, good afternoon, good evening. My name is Kumiko Usuda-Sato from National Astronomical Observatory of Japan, NAOJ. I would like to present Galaxy Cruise, NAOJ's very first citizen science project using the big data of Subaru telescope. The Subaru telescope is a large optical infrared telescope. Look at, this is the telescope photo. And the Subaru telescope is located on Mauna Kea, Hawaii. On its prime focus over here, HSC, Hyper Frame Cam, is mounted. Hyper Frame Cam, HSC, is a giant digital camera with a wide field of view. Look, this is a picture of HSC mounted on the prime focus. Using HSC, Subaru telescope is conducting an extensive survey program since 2014 called HSC SSP, Hyper Prime Cam Subaru Strategic Program. And in May 2019, the second data set was released to the world. So we try to make this big data accessible to everyone by releasing the HSC map general public version and Galaxy Cruise, our NAOJ's first citizen science project using the HSC SSP big data. So what is HSC map? HSC map is a kind of Google map HSC version. This is the initial screen of the HSC map. And inside of this green area extensive HSC data is hiding. And anyone can access to this HSC map without registration. So this is a URL. So please visit HSC map. And when you put your cursor inside of the green area, and you can zoom using your mouse or touchpad. And our Galaxy Cruise website uses the same engine. So on the Galaxy website, you can see the same function. In Galaxy Cruise, our citizen science project, citizen astronomers classify interacting galaxies to unlock the mysteries of galaxy evolution, such as how galaxies were formed and evolved. Look at this banner. In the background, you see many, many galaxies. This is a collage of interacting galaxies identified by citizen astronomers of Galaxy Cruise. So please visit our website of Galaxy Cruise. This Galaxy Cruise Japanese site was opened on November 1st last year, and the English site opened on February 19th this year. And as of December 1st this year, a total of 5,779 citizen astronomers have registered from 80 countries and regions. The number one is Japan. About 80% of citizen astronomers are from Japan. Number two is Russia. Number three, United States. Number four, Ukraine. Number five, Canada. And we developed our own original website and set up the 3 steps of the detailed training. All citizen astronomers must complete these 3 steps of the training before they start classification. Lesson 1, the shapes of galaxies. Lesson 2, what is an interacting galaxy? Number 3, 4 main features of interacting galaxies. So after these lessons, citizen astronomers can be confident to classify galaxies. And in Galaxy Cruise, we created the unique world view like a game. This project is likened to a cruise ship to sail the cosmic ocean. Look at this screen. So each citizen astronomer has her own voyage log. And look at this cruise map. This cruise map was created by arranging the observed region of HSC SSP. When you finish classifying one region, an anchor is marked on the region. And you also get the departure stamp on your passport. In addition, you can collect some souvenir icons when classifying galaxies. We are trying to interact with citizen astronomers. Number 1, we publish a new news article on the first day of each month. In some months, we explain for some received questions. In other months, we publish updates our voyage, the project. Number 2, commendations. We publish the name of active citizen astronomers in their honor when who have completed the stage 10. Stage 10 is the final stage. Number 3, sometimes citizen astronomers report unique shapes galaxies like Dwarf Galaxy or Jellyfish Galaxy. They are very unique interacting galaxies. So sometimes we post these images on our Twitter or Instagram accounts. As a next step, we are planning the machine learning to classify more galaxies by using the classification result by citizen astronomers of Galaxy Cruise as the tagged training data. In this August, through research experience program for undergraduate student, a college sophomore used the classification results of Galaxy Cruise. And he was successful to complete an artificial intelligence who could extract interacting galaxies with 91% accuracy. This is Seiji Toshikage. He is the sophomore of Tohoku University. This is his slide. And at last, this is my last slide. I have two announcements. Number one, the holiday season Classify 1,000 Galaxies in 1 month campaign will start in 3 hours, very soon. So please visit our website, Galaxy Secrets website, and classify many, many galaxies. When you classify 100 galaxies, an illustration of a snowman appears. And when classify 300 or 1,000 galaxies, you can add more decorations on your snowman. And what happens when you classify 2021 galaxies? Please see for yourself. Number 2, for Spanish-speaking people, I presented Galaxy Cruise, El Crucero Galaxia en español, en la Olimpiada Latinoamericana de Astronomía y Astronáutica. So please visit the official Facebook of this Olimpiada. Por favor, visiten su página oficial de Facebook y miren el video. Okay, I have some minutes, right? And
1 minute.
1 minute, great. Okay, so I want to show some website. Okay, can you see the screen?
Yeah.
Thank you so much. Thank you so much. So this is the initial screen of classification site of Galaxy Cruise. After you log in, you can see this site. So same as the HSC map. Inside of the green area, HSC data is hiding. So put the cursor over here and you can zoom in and you see many, many dots. Tiny, tiny dots are all galaxies. So you can explore freely the vast cosmic images captured by the Subaru telescope. And when you want to classify a galaxy, please click here and a galaxy comes out. Okay, and same as lesson 1, 2, 3. One galaxy has 3 questions. Number 1, is this spiral or elliptical? Maybe I don't see spiral features, so maybe elliptical. Number 2, is this galaxy interacting or not interacting? Must be interacting. Number 3, what kind of features do you see on this galaxy? Ring, fan, tail, or distortion? I think we see some fan or also tail or distortion. So you can select multiple features and submit. All done. And you, as I explained, you can see the voyage log over here, or souvenirs and passport stamp. Thank you very much.
Thank you.
That's all.
Very
Thank you.
Exciting. Yeah, very exciting talks.
Thank you so much.
Okay, so let's move to our next speaker. Our next speaker conference, CEA-Saclay, and about the European Exoplanets-A project. So welcome, Raphaël Peralta.
Hi, yes, welcome. Thank you very much. So, hello everybody. Thanks to all the organizers to let me introduce to present my work. I would have loved to be in Argentina, but unfortunately we cannot, maybe next time. So, yeah, I'm Raphaël Peralta. I work at CEA in France as a postdoc, and one of my job tasks is to develop pedagogical contents. And I would like to share with you some outreach resources that we have developed, such as a MOOC for a massive open online course on exoplanets and an augmented reality application on the solar system and exoplanets. So these education resources are developed for the Exoplanet-A project, which are available with this website, so exoplanets.eu. So here is the website, and we like to present this website as a knowledge server, because it is a website where we gather all the information, the scientific information about the project Exoplanet-A, and about as well all the learning information, pedagogical contents about exoplanets. So let me present a little bit the science page, which here you have all the scientific information about the scientific project, the scientific aspect of the project. So here is the space missions, so all the missions used for this specific project, which is about exoplanet again, with all links on the NASA, ESA, etc. Missions that we used, with all the data that we use. Here is the code, so all the methods that we have developed for this project. These are all new tools, new novels, a novel method to work with exoplanets. Here are the catalogs with the host stars, exoplanets, all about, again, with this project. So it contains all the database that we use or even that we have created, thanks all the methods created for the project. And finally, here you have all the publication of the project. And the second page is about the learning page, which gather all the pedagogical contents. So here you have again 4 windows. So the first one is about the video playlists. So you have different playlists all about exoplanets, again, from ESA or even others research institutes in different language, for example, in French, here in different language from ESA, or even in Spanish. Online courses, which is where there is a MOOC, so a massive open online course, and a SPOC for small private online course. Here you have the serious game. So there is a lot of contents called serious game. This is 3D models. This is models that you can manipulate. This is augmented or virtual applications that you can use for free. And finally, the data visualization, where you can manipulate some data and you can change the axis and you can get different data sets depending on what you want to show or to get. So let's start by presenting the MOOC on exoplanets. So here is so on the learning page, online course, you get the MOOC on the exoplanets. Here is the page for the whole presentation. For the moment, this MOOC is in French, but we are currently translating into English and in Spanish. So normally in January, you will have all the MOOC in 3 languages. This is free, so you can use it. Here, this is the link to the MOOC. So there is 9 modules. So the first one is about introduction. Then the definition between a planet and an exoplanet, what is the difference between them and what we know about them. Then it's about the distances on the universe. So how big is the universe? What it contains, like galaxies, stellar medium, etc. Then we talk about stars. So what is a star? How it works? What is their diversity, etc. Then we talk about the telescopes. So we present how we observe and how we detect new exoplanets. Then we talk about the atmospheres of exoplanets. So this is a very big deal right now. And we want to show how we study and how we observe these atmospheres. Then we talk about the habitability zone and the different combination with the star and the planet, how they communicate. Then we present the TRAPPIST-1 system, which is a good example to make an example of all the previous models. And finally, we finish the MOOC with the future space mission, such as JWST. So each model gets different levels. So normally there is 3 levels. The first one is the basic level for, this is the basic notions that we want the learner retain. And the other, and this level gets a quiz in order to test them yourself. And the others levels is especially to go further on a specific subject. So the specificity of this MOOC is to gather a lot of pedagogical contents. So you have, for example, to go further, a lot of links with, for example, links to see others' videos. These are in different language as well. We can as well to get some application, for example, Eyes on the Solar System from NASA. You can have as well some 3D models that you can manipulate in order to manipulate the system.
1 minute.
1 minute? Okay.
Yeah.
So here you have all, so we are translating and you can use then this. And the last thing that I would like to present you is the real augmented reality that we have created. So here's the link to download, and here is the image to work with the application. And it was widely used by the French association called Spacebus France. And it allows, so this application allows you to see, to manipulate, to test yourself with different quiz about our solar system, about different exoplanet system, and even about JWST. So everything right now is in French, but we are translating in different language. Feel free to use it, and if you have questions, or even if you want to translate in other language, please send me an email. Thank you very much.
Thank you, Raphael, and a very good talk, and a very good project. So the last speaker for this session is from SAAO from South Africa and Malagasy Astronomy and Space Science. Zara will give you a talk titled Leveraging ISTC and Online Platforms to Support Astronomy Postgraduate Students in Madagascar. So welcome, Zara. It's your time.
Do you see my screen?
Yeah, please open your camera.
I'm still, yeah, I'm looking for it. Let me quickly first.
Yeah, good.
Okay, now it's.
Yeah, please go ahead.
Okay, so hi everyone, I'm Zara Randriamanakoto. I'm currently a postdoc at the South African Astronomical Observatory, but I'm also actively involved in the development of outreach, but also research in my home country, Madagascar. And today I'm going to highlight the best practice, but also the challenge we face in running and implementing a postgraduate program in Madagascar. So first thing first, before I'm going further, I would just like to give you a brief overview of the current status of astronomy in Madagascar. It's already way back in the 1899 by Jesuits, but then they left in the 1960, and there is a revival when Madagascar joins as African partner countries of South Africa in its bid to host the SK project. And since then, students have been sent to South Africa to study, and there have been a conference in 2017 and the Zara project. And this is just a quick timeline over the 15 years where you can see that as I said earlier, 2006 is where the country became a South African partners. And then 2012, we have our first PhD student graduating at the University of Cape Town, and 2014 was the launch of the postgraduate program at the University of Antananarivo, that's the capital city of Madagascar. And the first cohort from that master's program, so it's a master's program, was in 2015. But in parallel, there was also the creation of Malagasy Astronomy and Space Science. So it's an organization that connect together the professional member, the student member, but also the amateur member of the Malagasy community. And that same year also, researcher based in South Africa started to supervise master students. I will talk more about it later. And we've also participated in the cohort of Zara, that's the Development in Africa with Radio Astronomy, a project led by the UK in collaboration with CEA, and the establishment of the Radio Astronomical Observatory that is managed by the Ministry of Higher Education. And during the last GA that was in Vienna, that's when Madagascar joined as the IAU observing member. And so far, as we speak, we currently have 10 Malagasy researchers with a PhD in astronomy and astrophysics. And most of us are still based in South Africa, but there is already a staff back in Madagascar. So as I said earlier, I will talk more about the postgraduate program. It's launched by Professor Minson Rakutumalal. He's a very passionate about astronomy, but he doesn't have a background in astronomy. It's an MSc degree hosted at the physics department, which means that you get a MSc in physics, not astronomy and astrophysics. And it's composed of two components: coursework that is run in French, that's supposed to be French, and dissertation that is going to be delivered in the thesis defense in English, but the book of the student also needed to be converted in French too, because the University of Antananarivo is still under the French system. The annual intake of that program is around 5 to 9 students, and the research areas that are being covered are extragalactic astronomy, cosmology, star cluster, galaxy evolution, and lately any science related to the SKA project, given the involvement of Madagascar and the researcher based in South Africa. So what are the challenges in running the program? The past, especially before 2016, there were low interest from BSc students to enroll in the program, and the quality of the program also was quite low, especially the dissertation component, simply because the researchers were not involved in the supervision of the students, so it was all done locally by the staff who didn't have background in astronomy. And the following challenges are still ongoing: a shortage of staff, lecturer with a PhD in astronomy. We only have one so far that is full position at the university, but also there is a really scarce job opening at the university, although there is one of our colleague that is undergoing the recruitment phase, and especially the inadequate research facilities. As I said earlier, we are involved in data related in project related to MIRCAT, like myself, Mighty MIRCAT data, and supervising students in that sense, mostly distance learning. It became a challenge, the internet, and there is no computer lab. The access to peer-reviewed journal, I already mentioned the data, and the student background in computer programming and astronomy in general. And there is also the language barrier, because we are mostly, they are used to French, but the resource and material are all in English. So there is really a need to leverage ICT and online platform, as well as informal training and education to address these issues. And in terms of leveraging the ICT and online platform, we know our deeply involved the Malagasy researcher based in South Africa in the supervision of the local student with the aim of increasing the quality of the dissertation. And through that interaction, more than 80% are all conducted online, be it a weekly meeting or bi-monthly meeting, and we use all available platform from Zoom to WhatsApp. We sometimes even talk to our students using Messenger. It's because they don't have a research facility at the university. They always have to go to the cyber cafe or they connect using their phone. So we just need to be flexible. And we also use quite a lot of archival data that are available online, such as the HST or SDSS survey. And in order of addressing the challenge in processing data like MIRCAT data, we collaborate with ITI, remote access of research cloud facility, one to do data visualization, but also to run script or do detection. But both parties really need to be committed and flexible for the program to be a success. But on the other end, we also really make sure that there is a skills transfer and capacity built in, because if you don't have a passion, if the students are not passionate enough, that's another reason of the dropout. And that's why the Malagasy Astronomy and Space Science comes to play, because we organize regular webinar and training workshop. So during this COVID-19 era, we launched the skills transfer. We choose a specific topic, and then we try to sharpen the hard skills of the students, such as teaching them Linux, programming, LaTeX, anything that they are interested and that we feel will be useful for them to complete the research. We also encourage them to write astronomy blog writing that we post in our social media. We make them participate in online outreach activities, journal club, the English club to improve their English, and you also run an annual the astronomy workshop.
1 minute left.
Yes, I'm almost done. So what are the outcome within these past 3-4 years? At least 12 students graduated, 3 of them are female, and 7 out of those 12 students are no postgraduate students in South Africa, the UK, and European countries. But also there are some of them work outside academia. Myself, I've been graduating 4 students. 2 of them graduated and are now working as PhD in Oxford University. 1 dropped out, and I'm still currently supervising another student. But we can really see that there is a positive outcome in what we're doing, because most of the students are not selected to be part of competitive program, and they even get grants that were really on a competitive basis. So distance learning and supervision definitely work. And what are the take-home message? That when there is a will, there is a way, but you also need to collaborate and to not wait for the best conditions to run something. Start now and use every means that is available. Thank you. I think I will stop there. There is my email and my Twitter account if you'd like to talk to me more. Thank you.
Thank you, Zara. Your work is very successful, I feel, yeah. So I would ask all the speakers here, turn on your camera, and we have several minutes for discussion and answer questions. Is there any questions?
I can help a little if you want, because I copied the questions in the file.
Yeah, sure.
Yes, there is a question by Christian Goes about, to Baerbel, and says, how can Latin American countries be linked to the project? Baerbel, are you there? Well, I know that Baerbel was answered the questions, but please try to, I select a few to be answering here in the space of discussion. Kumiko, are you there?
Yes. Hi.
Kentaro said nice talk, of course.
Thank you
Why
so
so
much.
many users of Galaxy Cruise in Russia and Ukraine? Are they the public people or young students?
Okay, thank you so much. I already wrote the answer, but when we released the news, some online article was published in Russia and Ukraine in Russian language. And in addition, a very influential YouTuber in Russia introduced our projects. That's why we receive many student astronomers from Russia and Ukraine. And actually, the age, actually, so about 30% of the registered student astronomers is about younger than 20 years old. On the other hand, very active student astronomers who classify many galaxies are mainly 50s and 60s. Did I answer your question?
Yes, I think it's a right answer.
Okay, thank you.
I must to mention that Kumiko prepare the Galaxy Cruise in Spanish because she speaks Spanish. So
let me. So our website is. We are so sorry. Our website is only Japanese and English, not Spanish. But in the Science Olympiad, I presented in Spanish with English slides. So yeah, thank you so much.
Well, Chenzhou, do you have a question from your side?
Yeah, I have an open question for all the speakers. Basing on your experience for education and for products, what is the biggest challenges for you to use astronomical data? Could someone answer their opinions? What is the most difficult, to use astronomical data for your education and product?
Can I answer from my perspective?
Yes.
As I already mentioned earlier, I think it's the fact that nowadays the astronomical data just become bigger and bigger, and just downloading those data, if you come from a country from Madagascar, it's really just a challenge by itself, accessing the data. Then processing it will be another story, and that's why we access cloud research facilities instead of, because as I said, our student is already by themselves that side, so it's better at least if we get them assistance then in processing or downloading the data. So we upload it for them in their personal account and then they access it afterwards.
Yes, thank you, Zara.
Christian is asking about the possibility to share or to participate in a radio astronomy project. It's a question for Baerbel also. And it's about how the college and institutions in Latin America can participate in radio astronomy projects. But I don't know if Baerbel is here. Anyway.
Yeah, maybe I can I give some answer for the collaboration globally. We are facing the challenges for big data, and the International Virtual Observatory Alliance community and the Austro Informatics community. We are working together to provide a science platform for the astronomers and community users. The science platform means we will combine public cloud computing platforms and storage, computing services, data mining services, and then for the end users and teachers, you don't need to download a large number of data sets to your local desktops or servers. Just use science platform portals, and then you will get the astronomical data with necessary computing services, resources, and software environments. So you can just use cloud resources to analyze the data and complete your projects. Of course, the process is still ongoing, and hope we will have a better and better platforms for the whole global community in the very near future, especially at the area of SK and Rubin LSST big data area.